Lesson 1 of Chapter 2 is on power functions. So the second part of the lesson is going to be on radical functions, but we're going to focus on this part of power functions. So the first thing I want to talk about is a monomial function. A monomial function is a function that has just one term, thus the prefix mono, right? It means there's only one term. So it's got to be in the form a times x to the n, where a is going to either be a positive or a negative number. Okay, and then n, the exponent, is either going to be even or odd. So when the leading coefficient, the a value, is positive versus negative, it's going to look different. Likewise with the exponent. If the exponent is even versus odd, the graph's going to look different, and that's what we're going to talk about here today. So, first one, if your leading coefficient is positive and your exponent is even, it's going to look something kind of like this. I like to call it a touchdown guy. Down below are the characteristics of a function that has an even exponent with a positive lead coefficient. The domain is all real numbers. The range is from 0 to infinity. The x and y intercept are 0. It's continuous everywhere, all real numbers. There's symmetry of the y-axis. There's a minimum at 0, 0. It's decreasing on the left side of the graph from negative infinity to 0. It's increasing on the right side of the graph from 0 to infinity. And you've got your end behavior down below here, saying both ends are going up. Well, if your exponent is even and your leading coefficient is negative, then it's going to look more like this. I like to call that a gorilla guy. And down below are all the characteristics of this type of monomial. You got domain is all real numbers. Your range is numbers less than or equal to 0. You got an x and y intercept at 0. It's a continuous function on its domain of all real numbers. There's symmetry of the y-axis. There's a maximum at 0, 0. It's decreasing on the right-hand side, and it's increasing on the left-hand side. And then the end behavior, as you go right or left, both ends are going down. Continuing on now, if we have a positive lead coefficient and an odd exponent, the graph's going to look something more like this. I like to call that a disco guy Randy because the right side goes up. And the characteristics are down below. The domain is all real numbers. X and y intercept at 0. It's continuous. There's symmetry of the origin. There's no mins or maxes, no extrema. It's increasing everywhere from negative infinity to positive infinity. And your end behavior is written down here. As you go to the right, it goes up. As you go to the left, it goes down. Well then, if your exponent is odd and your leading coefficient is negative, it's going to look more like this. That's what I like to call a disco guy Larry, because the left side's going up. And the characteristics are down below. You've got domain is all real numbers. X and y intercept at 0. It's continuous. Symmetry of the origin. No mins or maxes. You got it decreasing everywhere from negative infinity to positive infinity. And then the end behavior is written below. As you go to the right, it goes down. As you go to the left, it goes up. So you're going to be doing things like that, describing the characteristics given a certain equation. So it says graph and analyze each function, describe the domain, range, intercepts, and behavior, continuity, and where the function's increasing or decreasing. So I've got this one graphed already, but you can see we've got a positive lead coefficient, and the exponent is even. Therefore, it's a touchdown guy. So, domain, all real numbers, range from 0 to infinity, intercepts, there's an x and y intercept at 0. We have end behavior. As you go to the right, it goes up. As you go to the left, it also goes up. So there's your end behavior. It is a continuous function. And where is it increasing and where is it decreasing? Half of it is increasing. The half that's increasing is the right half, so we'll say from 0 to infinity. The other half is decreasing, so we'll say from negative infinity to 0. There's the characteristics of a touchdown guy. The next one they give us has a negative lead coefficient because there's a negative 1 in front of that x to the 7th. And if the exponent is odd, it's going to be a disco guy Larry. So talking about the characteristics, we got the domain, all real numbers. The range is also all real numbers. Intercepts, we've got an x and y intercept at 0. In behavior, let's see here, as we go to the right, it goes down. As we go to the left, it goes up. Continuity, this is a continuous function. And increasing behavior. To me, as you go left to right, this is always going down, so there's no increasing behavior. That symbol, again, is the empty set. It means that there's none. If you'd rather just write none, that's fine too. Decreasing behavior, then, is decreasing everywhere. Negative infinity to positive infinity. So this is what you're going to be doing on these examples. But let me expand this now. What's different about this graph is you can see we've got a positive lead coefficient, but this time our exponent is even, but it's negative. So then, instead of being a touchdown guy, where, you know, it's both ends are going up and away from each other, we're going to have a touchdown guy, but both ends are going up, but it's in the middle. Okay? So if we talk about all the characteristics, the domain on this is going to be all numbers except for 0. Why is that? Because really x to the negative 2 is the same thing as x squared on the bottom of a fraction. The 3 would stay on top, so when you look at it this way, you can tell that you can't put 0 into this function because you can't divide by 0. So there's the domain. The range, as you can see, it always stays above the x-axis. So we'll say 0 to infinity. That's greater than or equal to 0. Intercepts. There's none. Never touches the x-axis and it never touches the y-axis. In behavior. Well, as you can tell, as you go to the right on this one, it doesn't go up, it doesn't go down, it flattens out at a height of 0. Same thing here. As you go to the left, it flattens out at 0. Alright, next we have continuity. This is a discontinuous. It's infinite, discontinuous. And what else we have? Increasing and decreasing behavior. So as you go left to right, the left side from negative infinity to 0 is going up. And then the right side of the graph, as you go from 0 to infinity, it's going down. So there's your characteristics of a graph that has a positive lead coefficient, a negative even exponent. Last example has a negative lead coefficient and a negative odd exponent. So now it's not going to be like a disco guy. It's going to have one end going up, one end going down, but that's going to again be in the middle because the exponent is negative. So, talking about the characteristics. The domain on this is again all numbers except 0. And why is that? Because I could rewrite this function as negative 3 over 4x to the 5th. I could move that x to the 5th to the bottom of the fraction, and now you can see you can put any number you want into that except for 0. The range on this would be all numbers except for 0 as well, because you can see that it kind of flattens out at 0 as you go to the right, as you go to the left. Intercepts, there again are none. Never touches the x-axis, never touches the y-axis. The end behavior, as you go really far to the right, it flattens out at a height of 0. And as you go really far to the left, it flattens out at a height of 0. This is discontinuous, and it's infinite again, because it's going up and down at a certain spot of 0. And lastly, increasing and decreasing behavior. It looks like it's increasing on the left side and also on the right side. It's increasing everywhere on its domain. Decreasing doesn't have any, none. So this is what you're going to be doing in class, is analyzing monomial functions.